Next session is by Alexander Redkin, CEO of Syntacore. Sorry. Our title is a Syntacore open source and commercial RISC-V solution. And so Mr. Alexander Redkin is Executive Director and co-founder at Syntacore. Prior to establishing Syntacore in 2015, he had more than 15 years of experience in semiconductor industry in senior engineering and management role. Also, more than 12 years at Intel R&D, where he contributed both a number of research projects and volume semiconductor products development. Alexander's research interests are future SoC architecture and heterogeneous platform with specific focus on emerging workload analysis and acceleration. So, will you start your presentation?
Okay. Hello, everybody. My name is Alexander Redkin. Hopefully, you can hear me okay. And I'm going to start my presentation. Please let me know if you can see it all right. Okay, hopefully you can. And today I'm going to tell you about Syntacore open source and commercial RISC-V solutions. My name is Alexander Redkin. For those of you who are new to the ecosystem and not familiar with Syntacore, I'm going to start with a brief company intro, then I'll describe what do we do, both RISC-V compatible CPU IP and customization services. As a company, we are IP provider. We design and license RISC-V compatible CPU cores, and we believe these are state-of-the-art. We are founding member of RISC-V Foundation and have been focusing on RISC-V designs quite for a while. We have almost 6 years of focused RISC-V development. And everything which we describe today is immediately available, silicon proven at the customers, and in quite few cases already ships in volume in full wafer production. Core team, which core engineering team, which is in Syntacore, comes from more than 10 years of highly relevant CPU design background. Everything we provide comes with full expected collateral, SDKs, sample and silicon, etc. I'll describe that in some details later on. This is one part of what we do, and the second part is we provide full service to specialize CPU IP for customer needs. We do it as a one-stop turnkey service, and we can approach that specialization, such specialization projects differently. We can start from customer specifications, if there is some, and we have projects like that, or we can start early. We can work together with the customer to define what extension is needed and what specialization to the core or multitude of cores is needed. And we can start as early as from workload analysis. For example, we can look into workload in any form like MATLAB, model or C++ implementation, analyze it, design ISA extension, approve it with the customer, show benefit, and then go and implement it, including toolchain and compiler. And this is our background. Our entire flow is built in a way which enables quick creation of such derivative IP. These are types of projects we are specifically interested in, and we have quite a few ongoing projects of that kind. Besides of that, we are also doing more traditional services like IP hardening and SoC integration to software migration support. A few words about company background. As I mentioned, we were established back in 2015. We currently have slightly more than 70 employees. Most of them are engineering. Legally, we are structured with headquarters at Cyprus, which is European Union, but our main R&D offices are in Russia, in St. Petersburg, Moscow, and we actually have a third one currently as well. We have representatives in all major geos. In Japan, we are represented by Syntacore. There will be contacts in the end. As described, core team comes from strong CPU design background and major multinational. And while there, some of the cores and SoCs we've developed or contributed to were at the time at mass production. We have a lot of relevant expertise. Some current results. We have state-of-the-art line of RISC-V compatible CPU IP with competitive and comprehensive features, 8 cores in total. These are commercially, all of our IP is licensed to several customers typically and deployed commercially in SoCs up to 5 nanometers. We have referable clients in all basic or all main geos or regions in Asia, EMEA, US, and there are both MPWs and full-wafer production based on our designs at the clients. We think we should be in higher hundreds of thousands of chips, like overall, and there are quite interesting project examples. For example, there is 60-core SoC, where all the cores, the entire control plane is based on our design, 64-bit, heterogeneous, very advanced customization. Very interesting project, quite a sizable at 7 nanometer. For those who are not familiar with what we do, this is how our current roadmap looks like. We have 5 microcontroller class designs and 3 application class, and we expect to have several actual additions to our product line by the end of this year. This is at glance features of our product line. I'd like to start from stating what everything we do is clean slate in-house designs, so we do not derive any open source components, and everything we do is very traditional system Verilog based very traditional system Verilog based designs. highly configurable and extensible, obviously, which is sort of attractive for the space, and 100% compatible with major EDA flows. So I'm not going in full details about features of our course, but I think they are quite comprehensive. I'll stop in some additional details about ECR1 and like entry-level design, which is open source, and later about our mid-range efficient application core, ECR7. But here I'd like to name few interesting features. For example, for our microcontroller class cores like ECR3 or ECR4, we support both 32 and 64-bit instances, and also provide possibility to instantiate those in multi-core clusters, including heterogeneous configurations. So, for example, customers can create a mix of different cores working together over coherent memory. And not only microcontroller class, but microcontroller class and Linux-capable like application class cores can be mixed together. Currently, like immediately up to quad core and up to 8 or 16 in close perspective. All the cores have advanced features. For example, even in microcontroller class, you can have a choice of tightly coupled memories and more advanced cache-enabled memory subsystem with ECC, parity, etc. Full-featured MPU, advanced debug features, including parameterizable counters, trace. We support in-ROM debugging, etc., and choices of AMBA-compliant interfaces. Now I'd like to spend a few moments talking about ECR1. This is our entry-level design. If you are familiar with Cortex product line, this is very close to Cortex M0 to M3 type of design. It covers that entire range because it's configurable and can be configured for small footprint and tiny implementation, or more with more features for higher performance. What is interesting about that design, it's completely open and free to use, and with that, it's also industry grade. It taped out multiple times in different companies, including full-wafer production, and it's very neat, compact, entry-level MCU design. It comes, it's not only core, it's full all the core features are included, including IQ controller, debug controller. There are choices of ALU, area optimized, performance optimized, etc. It has been published for actually it will be 5 years soon under a very permissive SHL license, which is Apache 2.0 derivative, is hardware specific, and unrestricted commercial use is allowed. It's very popular on GitHub and comes with full collateral. There is this bench, verification suite, SDK, specifications, software, and we even provide best effort support. And if you need more guarantees or you have some customization project based on that design, have some specific features which you need, you can talk to us and we can provide extra services on commercial basis. Here are some numbers. We think they are quite competitive for the space, for the entry-level microcontroller class design. You can get up to 3 core marks per megahertz with that design. And there are several pre-built configurations which work out of the box. For example, the minimal fully functional EC enabled config is just 11 kilogates. That includes basic debug and RQ delivery capability. And more traditional, higher performance IMC config would be 30 plus kilogates, but practical range is from 10 to 40. And it can be clocked at more than 250 in TSMC 90LP. Besides, design gets regular updates. For example, we added later support. You don't even need to use commercial EDA to do something with the design. And there are flows which allow to run it out of the box in all major SIMs and later, and it gets regular updates. For example, then compliance test suite makes progress. We make sure all these tests can run on that design. Besides of the core, we also provide SDK. Our approach to that, we use and support several low-cost boards, standard boards, FPGA boards from different vendors. And for those boards, you can find on GitHub fully open designs, which are easy starting point for any derivative works, and also pre-built images. It's not only hardware part of design which is included, but also a full software stack, including first-stage bootloader, real-time operating system, test and application samples, and pre-built toolchain. There is also extensive documentation. Overall, we think this is one of the easiest paths to start doing something with RISC-V, and it's also useful and practical design at the same time. That's what makes it popular, we believe. So on the other range of our product line is ECR7. This is efficient mid-range application core, RV64GC ISA. It can do SMP up to 8 cores per cluster immediately, based on a flexible microarchitectural template, which does out-of-order execution. Fully Linux capable, can be clocked about 1.5 gigahertz in 28 nanometers. Achieves more than 5 core marks per megahertz per core, and is very competitive with Cortex A55, almost 20% more higher performance than A53. We don't have detailed numbers for A55, but ARM reports it to be about 18% better in spec-int over A53, so we think we are very competitive. Besides of the core, we provide fully featured software development suite based on the open source components, which we basically integrate and release this way. Support number of low-cost JTAG connectivity solutions, and work with every available vendor to make sure our cores are supported. So majority of our cores are already supported, and we are working with vendors to extend coverage now. With every core, we also provide fully featured SDK with basic system built around core and software stack, etc., similar to what we did for ECR1. We also provide customization services because I'm short on time, because let's start. I'm going to skip that part. If you are interested, just contact us. It's a separate topic of its own. Can go deep and wide. There is some example you can look after online. And if you are interested to do something with our IP, it's very easy to get evaluation. You can get full package for any experiments after a very simple evaluation agreement, and ECR1 is fully open. This is what is included in the package for your reference later on. And with that, I'd like to conclude. We offer high-quality RISC-V compatible CPU IP. We are founding member, have been doing that quite for a while. Majority of IP is silicon-proven and ships in full-wafer, and we provide turnkey customization services with full tools compiler support. If you need local contact in Japan, please contact Mr. Katsuhira Katayama and the contact which is included. Thank you very much, and I again apologize for the late start. I'm not sure if you have any time for questions. Maybe we can take them offline or later in the chat.
Oh, yeah. So, thank you for your good presentation and very impressive. And your IP core is very almost complete. And yeah, can I have some question to you? So your company is IP providers and IP license, is that right?
Yeah. Yes.
No. So then, so just a kind of a last question, maybe. So you already have some licensee also. Now it's just evaluating also.
Yes, we do have multiple licensees, several in every major geography, like region, several in Europe, several in US, some in China and Asia region, and they are referable. We don't do a lot of marketing, but if you are interested, we can put you in touch and you can get references firsthand.
So you already have some chip, and your evaluation board already have some chip. So these chips are made by your company or some partners also.
So yes, by default, we provide FPGA-based evaluation boards, but there are some chips based on our designs. It's just they belong to the customers, and we cannot use them as evaluation boards. There may be some options like that soon, but not immediately available. Right now, we provide FPGA-based evaluation boards.
So, yeah, thank you for thank you for answer to my question. And just to confirm, not so question from audience. So just already done this. Thank you so much for your good presentation.
Thank you.
And very effective.